This here is the SSL 4000E channel strip plugin from Universal Audio, an emulation of the solid-state Logic 4000E console. I believe if you clicked on this video, you already know what it is. Its well-deserved hype has probably already reached you, and you just want to understand how it works and how to use it to its full potential. That's what this video is all about. Yo guys, I'm B-Man and you're welcome to the video. Let's scan this tool. From left to right on this diagram is the signal flow. Let me explain how it works. As you would naturally expect, the signal first enters at the input preamp module. The controls associated with this section are, first, the line gain. The line gain has a range of plus minus 20.5 dB. To increase the line input gain, rotate the knob clockwise. Here's a quick tip. Clicking on this zero text label returns the line gain to its center unity position. Directly below the line gain, you have the mic gain. The mic gain knob has a range of minus 20.1 dB to plus 70 dB. Rotating the knob clockwise obviously increases the mic gain. Because this is a Universal Audio emulation, you get the added advantage of unison technology on your Apollo hardware to adjust both the line and mic gain parameter. The remaining controls on the input section are flip, which is the input select. Clicking on flip determines which knob, either the line or mic, is used for input gain adjustments. Flipping to line illuminates the green LED indicator next to the line gain knob. The red LED illuminates when flipped to mic. Then right below the flip, you have the transformer, abbreviated XFMR. This enables the Jensen transformer emulation for the mic preamp. Depending on the signal, this can bring additional richness and warmth. Disable XFMR when you desire more clarity. You should also note that this control has no effect in the line input mode because it has no transformer in its signal path. Right below the transformer, you have polarity. As you already know, it inverts the polarity of the signal. Leave the button out for normal polarity. Then right below the polarity, we have pad, indicated here as minus 20. The pad button reduces the input signal by 20 dB. Pad can be switched with the minus 20 button in the plugin's interface or with the Apollo's hardware pad button. Right below the pad, we have the preamp overload LED. This indicates when signal clipping is occurring at the input stage. The indicator remains illuminated for 1 second right after a clip is detected. You should note that overload does not indicate clipping when the plugin is used in a unison insert within the console application. From here, the signal flows into the dynamic stage. This section gives you the independent soft neck compressor limiter and expansion gate modules. Both modules have two distinct colors. The compressor limiter controls have gray knobs and the expander gate controls have green knobs. It's important to note that the signal first enters the expander gate module before it goes into the compressor limiter module. However, to keep this tutorial visually organized, first let's talk about the compressor limiter module, starting with the compressor link. Here's the thing though, when this plugin is used in a stereo configuration, you actually have two separate active compressors for both the left and the right channel. Engaging the link button constrains both compressors, so they compress both channels by the same amount at any instant. So link basically prevents transients which may appear only on one channel from shifting the stereo image of the output. On a mono track, the link has no effect. You then have the compress ratio right after. I would safely assume you already know what compression ratio is. This plugin offers a continuous variable ratio of 1:1, which is no compression, right up to infinity, which basically becomes limiting. A ratio of 2:1, for example, which is represented here by the number 2, reduces the signal above the threshold by half. So an input signal of 20 dB gets attenuated by 10 dB. You then have the compressed threshold. The available threshold range is plus 10 dB to minus 20 dB. This compressor has an automatic makeup gain function. As threshold is lowered and compression increases, output gain from the module is increased automatically to compensate. Here's a quick tip. Click on the 0 text label to return the compress threshold knob to its center position. You then have the compress release, another control you should already know. The SSL 4000E release time is continuously variable between 0.1 seconds and 4 seconds. Right beside the release, you have the compress fast attack. This can easily go unnoticed if you don't pay attention. The compression attack time is program dependent and automatically varies between 3 milliseconds to 30 milliseconds when the switch is not engaged. When engaged, it has a fixed attack time at 3 milliseconds for 20 dB of gain reduction. Let's then talk about the gate expander module. The gate expander module operates in either gate or expansion mode as determined by this dynamic select button. This select button cycles through the 3 modes available in the gate expander module. You have the expander, the gate 1 and the gate 2. Expand, here as EX. In expand mode, downward expansion is applied at a fixed 1:2 ratio with the amount of gain reduction determined by this expand range control. Gate 1, here as G1. In gate 1 mode, signals below the expand threshold are attenuated by this expand range amount. The gate 1 is authentic to the gate mode on earlier hardware consoles. Gate 2, here as G2. Gate 2 operates the same way as gate 1, but has a different response characteristic that is derived from later versions of the SSL hardware. You then have the expand threshold. This sets the input level at which expansion or gating occurs. Any signals below this level are processed. Signals above the threshold are unaffected. The threshold here is continuously variable from minus 30 dB to plus 10 dB. Let's talk about this expand range. The range, which you can also think of as depth, controls the difference in gain between the gated or expanded and non-gated or expanded signal. Higher values increase the reduction of signals below the threshold. When set to 0, no gating or expansion occurs. Range is continuously variable from 0 dB to minus 40 dB. You then have this expand release, which sets the amount of time it takes for gate or expander processing to engage once the signal input drops below the threshold value. The available range is 0.1 milliseconds to 4 seconds. Just like the compress fast attack we already mentioned above, you also have the expand fast attack. This lets the gate expander module set the duration between the input signal reaching the threshold and the end of dynamic processing. Expansion gate attack time is fixed at 1.5 milliseconds per 40 dB of gain reduction when this switch is not engaged. When engaged, the attack time is fixed at 100 milliseconds per 40 dB of gain reduction. On some much more serious controls, you have the dynamics enable. I call them more serious because without them, every other control we just mentioned is actually inactive. These 3 buttons determine the operating status of the dynamics processors. You have the dynamics in. This button enables both the compressor limiter and the expander gate modules. Neither module will function when GYN in is disabled. You have the expander in. This button enables the expander gate module. The button has no effect when dynamic in is disabled. Lastly, you have compress in. This button enables the compressor limiter module. As expected, the button has no effect when dynamics in is disabled. To crown the dynamics section, you then have the dynamics meters. The expansion meters uses grain lead to display the amount of downward expansion occurring in the expander gate module. Higher values indicate more gain reduction. The compression meter uses amber and red leads to display the amount of gain attenuation occurring in the compressor limiter module. Higher values indicate more dynamics compression. You should note that all the processing that happens in both the compressor limiter module and the gate expander module flows into a VCA circuit. From here, the signal enters the EQ stage. Here it gets even more interesting, and I'll explain why. Yo guys, I need you to help me make more of this. You already know what's up. Hit the like button. Let me know your thoughts in the comment section and don't forget to subscribe. The SSL 4000E channel strip EQ model is divided into 4 frequency bands. While the high and low bands can be switched from shelving mode into bell mode, the 2 mid-range bands are fully parametric, just bell mode, either a peak or a dip. 2 different types of SSL EQs are available on this plugin. The EQ type select button over here lets you choose between the 2 types. You either have the black or the brown. The knob color of the low frequency band controls always change to reflect the current EQ setting. Black in black setting and brown in brown setting. Note that even though all EQ knobs don't change color when switching EQ type, all the EQ bands actually get affected by the EQ type. While the black and brown sound different, black is also a bit more surgical, while brown is more gentle at extreme settings. Now let's get into more details with this EQ section. First, at the very top is the high frequency gain. This knob lets you boost or attenuate the high frequency. Then below that, you have the high frequency knob. This knob determines the frequency range to be boosted or attenuated by the above gain knob. The available high frequencies in this section go from 1.5 kHz to 16 kHz. The bell button switches the selected high frequency band from its default shelf mode to a peak or dip mode. In its normal shelf mode, only frequencies above the frequency value are boosted or attenuated. In bell mode, frequencies above and below the frequency value are boosted or attenuated. Right below the high frequency band is the high mid frequency band, abbreviated as HMF. Just like above, you first have the high mid frequency gain. This control determines the amount by which the frequency value for the band is boosted or attenuated. Below that, you have the high mid frequency select knob. This lets you select the center frequency in the high mid frequency band to be boosted or attenuated. The available high mid frequency range on this band goes from 600 Hz to 7 kHz. You then have the high mid frequency cure directly under the high mid frequency gain knob. Rotating this knob counterclockwise gives you a much more steeper slope, and clockwise gives you a wider slope, as you can tell from the indicators under the knob. Right below is the low mid frequency band in all blue here. Just like above, you first get the low mid frequency gain. This control determines how much the selected frequency gets boosted or attenuated. Below that on your right, you have the low mid frequency select. This does the same thing as in the band above. The available low mid frequency range filter goes from 200 Hz to 2.5 kHz. You then have the low mid frequency cure directly under the low mid frequency gain knob. Rotating this knob counterclockwise gives you a much more steeper slope, and clockwise gives you a wider slope, as you can tell from these signs under the knob. Right below is the low frequency band, abbreviated as LF. First, you have the low frequency knob. This knob lets you set the frequency to be boosted or attenuated. The available low frequency range shelving filter goes from 30 Hz to 450 Hz, with this switchable bell curve directly below it to switch from a shelving filter to a bell filter. As expected, you have the low frequency gain. This control determines how much you boost or attenuate the low frequencies. Here's a general tip across all EQ bands. Clicking on the 0 text label on all gain knobs returns the gain knobs to their center unity position. This leads us right to the available EQ setting options. These 3 buttons determine the status of the EQ module. First, EQ in. The EQ in button enables the whole EQ section. Second, you have EQ dynamic sidechain. This control enables the EQ sidechain function. When the EQ sidechain function is active, signal output from the EQ module is removed from the audio part and is instead routed to control the dynamics module. This basically sends selected particular frequencies to trigger the compressor. You then have pre-dynamics. This swaps the signal flow and instead put the EQ model before the dynamics model, basically letting the signal flow through the EQ before reaching the compressor. You should also note that pre-dynamics is unavailable when dynamic sidechain is engaged, which means if you choose to set particular selected frequencies to trigger the compressor, for example, you can no longer route the EQ section to come before the dynamic section in the signal flow. To listen to the sidechain signal, simply disengage dynamic sidechain to hear the equalized signal. You should note that the EQ model must be active at the same time with the EQ dynamic sidechain button for the EQ sidechain to function. So basically, when the EQ is off, you cannot send selected frequencies to trigger the compressor. If you guys remember from the video I made on the Avalon VT737, you can tell it's the opposite, because on the Avalon, the EQ sidechain can work even if the EQ model is switched off. You then have the EQ overload LED. This LED illuminates when clipping occurs in the EQ amplifier. You can always adjust EQ and input gain parameters to avoid clipping. From here, the signal flows into the filter stage. In addition to the 4-band EQ, the SSL E-channel strip offers individual high and low pass filters. When a filter control is at minimum value, which is fully counterclockwise, that filter is disabled. The color and sonics of the filter knobs change to indicate the selected EQ mode, with the knobs being a lighter gray in black mode as it is already, and a darker gray in brown mode. You see, you first have the high pass filter which ranges from 16 Hz to 350 Hz, and a low pass filter which ranges from 3 kHz to 22 kHz. In black mode, the slope of the high pass filter is 18 dB per octave, and in brown mode, the slope is 6 dB per octave. The slope of the low pass filter is 12 dB per octave in both brown and black modes. Here's a tip. Click the out text label to return either filter knob to its default disabled position. Here are other available extra filter settings. First, you have filters to sidechain, abbreviated DYNSC, dynamic sidechain. When filters to sidechain is enabled and active, signal output from the filter module is removed from the audio pad and is instead routed to control the dynamics module sidechain. You can use this to determine which frequencies gets fed into the compressor. Note that pre-dynamics is unavailable when dynamic sidechain is engaged. To listen to the sidechain, simply disengage dynamic sidechain to hear the filtered signal. Also note that the filters model must be active together with the filters dynamic sidechain button for the filters sidechain to function. When filters pre-dynamic is off, which is its default setting, the filters model is located after the dynamics model and after the EQ model if EQ pre-dynamic is off. When filters pre-dynamic is on, which basically means filter before dynamics, the filter dynamics model placements are swiped, so audio output from the filters model is instead routed into the dynamics model. Also take note that pre-dynamics is unavailable when dynamic sidechain is engaged. From here, the signal goes into the output section. Here, the signal first goes into the level fader, this right here. This fader sets overall signal level in a range from infinity, which is silent, to plus 10 dB. You then have this output meter. This vertical LED style meter provides a visual indication of signal levels at the output of the plugin after the level fader. The hold button enables peak hold mode for the output meter, which maintains a red peak LED for 3 seconds after a signal clips. Hold also applies to the preamp and EQ section overload LEDs. This basically helps you observe and prevent clipping, especially if it's abrupt. Then right here, everything finishes at the output. Output adjusts the signal level at the output of the plugin without affecting the sonic character of the signal. The available output range is plus minus 20 dB. This control, which does not exist on the original hardware, facilitates the ability to maximize color of the overall signal. For example, you can crank up the preamp gain and the fader for more distortion, while lowering the output to normalized levels. The very final control is this power button. This is basically your bypass on and off button. I understand this was a pretty long one, guys, and if you stayed to the end, I appreciate you. If there's anything you don't understand or just need more clarity on, let me know in the comment section and I'll be happy to clarify you. The SSL 4000E channel strip is one of the best out here, and Universal Audio actually, in my opinion, outdid themselves with this emulation and everything it has to offer. That's it for this video, guys. Please don't forget to like and subscribe, and see you all in the next video. Take care.